Assalamualaikum warahmatullahi wabarakatuh. This video will show you the effect of error level analysis on the image forgery detection using deep learning by Said Azhari. Abstract. Digital image modification or image forgery is easy to today. The authenticity, verification, and of an image become important to protect the image integrity. So that the image is not being misused. Error level analysis or ELA can be used to detect the modification in image by lowering the quality of image and comparing the error level. The use of deep learning approach is a stage of third in solving case of image data classification. This study want to know the effect of adding ELA extraction process in the image forgery detection using deep learning approach. The convolutional neural network or CNN, which is a deep learning method, is used as a method to do the image forgery detection. The impact of applying different ELA compression levels, such as 10 or 50 and 90%, were also compared in this study. According to the result, adopting the ELA feature increased validation accuracy by about 2.7% and give the better the accuracy. However, the use of ELA will slow down the processing time by about 5.6%. Introduction. Image data is extremely prone to manipulation in today's digital environment. Image editing software is widely available today, and it may be used not only on desktop computers and laptops, but also on handheld mobile devices. A deep generative model is commonly used to create hyper-realistic face swapping, image, and video in some applications. People commonly exploit the outcomes of this image manipulation in social media and the commercial world, and even for criminal purpose. For illegal purpose should be a major source of concern, since it can pose a serious threat to society, government, and industry. As a result, the validity of the image in the internet must be confirmed, so that maintaining the integrity of digital photography is crucial. In this situation, an image forgery detection method can be used to verify and validity of digital image. And then the digital image forensics. This is a part of introduction, or DIF is a field to detect the authenticity of digital image, both in terms of the image content integrity and the source. Active and passive modification detection technique are two types of algorithm for detecting features forgery in DIF. The method of passive forgery detection does not need any prior knowledge of the image content. The active technique, on the other hand, requires extraction watermark and digital signature embedded in the image and verifying them. As a result, any modification to the image can disrupt the embedded watermark and digital signature, assisting in the detection of the image validity, the copy and move, or cloning. Then, several studies on digital forgery detection have been carried out with various approaches. Resulted Dehni et al. discuss a digital image forensic technique to distinguish this difference is captured in terms of residual image properties, or noise pattern is the case of digital camera image extracted by wavelet-based denoising filter. The result of this study indicate that the two types of residuals obtained from different digital camera image and computer generated image have some general characteristics that are not present in other type of image. To the part of the research method. Image datasets. This study used photo image data from high resolution digital camera as the dataset. A copy move the modification is performed on the original photo. The original photo and their modification has a total of 20 images. The pattern recognition lab, computer science, Friedrich Alexander University, Erlangen-Nuremberg provided dataset of transformed image for this work, including 48 images for each category of original and modified image. The dataset from the Cassius ID dataset, which was also used in the What If et al. Study, has been added as well with a total of 50 and 10 images. This is an example from the effect of error level. We can see picture A, the original image, and B, forgery image. Such meaning picture B has been edited. To figure 2, data set example of copy and sampling. Picture B, the original image, and B, picture A, the original image. Picture B, copy movement and scaling. And picture C, copy move and rotating objecting. As the meaning, picture B and picture C has been edited. We to the part or error level analysis or ELA. Error level analysis is technique used to detect image manipulation by restoring the image at the certain quality level and calculating the ratio between compression level. In general, this technique is performed on images that are in a lossy format. The image type is used in data mining is JPEG. In JPEG image, compression is performed independently for every 8 pixel in the image. If an image is not manipulation, every 8 pixel in the image must have the same error rate. 3 different levels of image compression were examined in this article, namely 10% or 50% and 9% compression. Deep learning architecture. Deep learning architecture in this research has been tried to detect modified image using deep learning method, which is inspired by the visual cortex technique. Technically, this network is designed to extract relevant features from classification, namely those that minimize loss function, network parameter, and kernel were trained by the gradient distance method to produce the most discriminating feature of the rendered image to the network. These features are then assigned to the fully connected layer to perform classification. So we can skip The device used for testing has Intel Core i7 specification with 12 GB RAM. The implementation of the CNN architecture use the Keras library in Python. We can do the quality of image in Core i7 maybe or i5. We can use to. This is a different with using LA internet analysis or error. I mean different between using error level analysis and doesn't using error level analysis. We can see which array using original image, and picture B modified image. Conclusion. According to the experiment, LA can be applied to the cell to increase the accuracy results of digital image forgery detection. The accuracy of the training model on average reaches 0.8 0.86 for the use of LS, 90% the use of LA, 10% and 5% result in an accuracy of. Meanwhile, detection accuracy using CNN without LA is 0.83. When compared with the result without the LA, the accuracy of the training model is better using the LA feature. Likewise, when viewed from the accuracy validation, it will show the superiority of using the LA feature with a significant difference using the test. The best accuracy is obtained when using LA, 90%, whereas the maximum accuracy is obtained when using LA, 10%, and validation similarly when averaging using test data. LA 50% reduces the highest test accuracy value, despite the fact that it is not significantly different from the others. However, using the LA function will slow down the detection process slightly as compared to not using it. In addition to classification or image forgery detection, future research is intended to provide information on the modified pixel region with better accuracy. I think just that I wanna say thank you for your attention. Maybe there's a wrong. I'm a study as a student. Thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.